So today we will speak about field symbols and how we can create dynamic data allocations in ABAP using object-oriented ABAP classes. So that's all we will talk about today. So to understand the concepts of dynamic data allocation, first we need to look into the concept of field symbols. Most of us are already aware of this because it's a basic ABAP concept, but still just for repeat, I will explain it to you, and then we will move towards a creation of dynamic data types. So field symbol are placeholders or symbolic names of other fields. They do not physically reserve any space for a field, but point to its content. So a field symbol can be a point to any data object. So basically, you have your memory allocated, and a field symbol is a pointer which can point to that memory. So data objects to which a field symbol points is assigned to it after it after it has been declared in the program. So first of all, you will declare your data object. It could be a random memory or it could be a variable which is properly typed, and then your field symbol has to point it to that memory in order to access that memory. So for that, you need to assign the field symbol to the memory. So whenever you address a field symbol in a program, you are addressing the field symbol, the field that is assigned to the field symbol. So after the assignment is done, when you are referring to your field symbol, it is exactly as if you are referring to the field. So after the successful assignment, there is no difference between ABAP, whether you reference to the field symbol or the field itself. So they both becomes a kind of access point to you to access that memory, whether it's a variable or the field symbol which is assigned to the variable. So you must assign a field symbol to each field symbol before you can address it later in the program. So the assignment is very important. When you declare your data variables, whether it's properly typed or not typed, your field symbol has to be assigned before you access that using field symbol. So field symbols are similar to dereferenced pointers in C. That is pointer to which the content operator star is applied. However, the only real equivalent of pointers in ABAP, that is variable that contains a memory address, is the field symbol. So the pointer concept, if you talk about, that's actually the field symbol in here. Now you can see in the picture there's a memory which is allocated by data statement, and there's a field symbol. So after I do assign this memory to the field symbol is going to point this memory. And now you can use this field symbol to change the memory data, to change the data which is there on the memory. So what are all the advantages? Why do we use field symbol? That's a more important question here. Why can't I just directly use the variable name? Instead, why do I prefer to go with the field symbol? The advantages are we directly deal with the memory as far as field symbol is concerned. So it will be effective, especially when we have to change the data without any additional variable. So I'll show you a small example wherein we will create an internal table and we'll try to change the data into internal table. We'll see how it can be done with the work area, and we will see how it will be done with the field symbol more efficiently. Another advantage is when we do not know the type of the data which we want to access. For an example, you are running a program wherein you need to declare an internal table, and the type of internal table is not known until runtime. So at design time, you don't know what will be the type. Will it be VBAP? Will it be VBAC? Or will it be MARA? What will be the exact type? You don't know the type of the internal table you want to declare, and the type will be known at runtime. So you, based on user actions, you will be deriving the type, and that time you need to declare an internal table using that type. So at runtime you will be knowing the data type of the variable. At design time you will not be knowing. So to declare such variables like internal tables, structures, or variables which can point to dynamic memory, we need the field symbols. The third main advantage is dynamic data allocation. That also we are gonna see today. Both approaches, the basic ABAP approach for declaring data dynamically, and object oriented ABAP approach for declaring data dynamically. So the field symbol is gonna play a very important role there to point to your dynamic memory. The syntax to declare field symbol is field hyphen symbols. then you have to enclose the field symbol name into stereo sign type or structure and the data type for which you want to create a field symbol. So for field symbols, the angle brackets are part of syntax. So you can see here there's an angle bracket which is part of my syntax. So when I'm declaring field symbol, my field symbol name should be enclosed into angle brackets. So they identify the field symbol in the program code, and to assign the field symbol we use assign statement. So let's look at our first simple example of using the field symbol as far as the internal table is concerned. So what I need to do is I have an internal table which has two columns A and B, and I want to change the data in this internal table. So let me create first this internal table into my basic ABAP program. So I go to ABAP program. I click on create to create ABAP program. So now in that ABAP program, I'm going to create an internal table first of all. So I use data, begin of itar, occurs 0, column A type C, column B type C, end of itar. And now I'm going to create a work area like line of itar. So let's insert some data. So use a form, add data using character A, or let's say X, comma 10x, or probably I'll create it as integer type 10x and 20y. I add this perform as form, add data using p underscore a value, p underscore b value, and form a work area hyphen a equals to p underscore a value and work area hyphen b equals to p underscore b value. Now append this work area to internal table. That's the way two records will be appended. After that, I clear my work area. Now from here, the use of main thing starts. So you have an internal table which has two rows now, 10x and 20y. Now my requirement is to change the cell B value with the value Z. So with the work area, how am I gonna do that? First of all, I need to read the record which needs to be changed into the work area. That is my first step. So as far as my first step is concerned, read data into work area which is subjected to change. So I read the data. So probably I read table itab into work area index 1. That's my first row. Sorry, index 2 I'll do because the data which I need to change is in the second row. In the next step, I need to change the data into work area. The work area hyphen column B value, I will change the value with Z. So instead of Y, it will be changed to Z. Now in the step 3, modify the table from work area, because work area contents are local contents. Now you need to modify your internal table. Modify table iTab from work area index, or probably the syntax is modify iTab from work area index 2. So whatever is the content in the work area which is updated will be transferred back to the internal table. So these are all my 3 steps to do that. So now if you observe here, the work area itself is a separate memory which is being consumed when I'm writing my program. I'll write also a small subroutine to print the data. So write statement for edit, and after edit. So in my print content form, I'm gonna just print the content of internal table. Loop at iTab to work area, and write statement work area hyphen A comma work area hyphen B. So the columns I'm gonna print. So now we will see the data content will be changed from in the second column, or I would say second cell of second row. So I will activate the program now and we will see how it will behave. So now my program is active. So now I will execute my program to see how it changes. So you can see before edit the content was 10x, 20y, and after the edit the content has become 10x and 20z. So this cell is being changed from the work area. So this process I did it in 3 steps. First I read the data, I change the data into work area, and then I modify the data in the tab from the work area. So these are all the 3 steps you have to do in order to change the data. Now consider if you have 500 internal tables, you have to create 500 different work areas for editing the data for that. Now what could be a solution wherein I can directly modify the data without doing much of this operation of reading, changing locally in the work area, and then modifying the table again. So all of these 3 can be simplified into one single statement, or probably 2 single statements after the read. So what we will do here is we will write a field symbol. So field symbol, as I mentioned, that these are equivalent to dereferencing pointer. So once you write the field symbol and you read the row into the field symbol is going to actually point the row. Instead of copying the data from the table to work area, it will directly point the row. So far in the first case, we have read the data, changed the data, and updated the data back. Using field symbol, you just assign the row of the table to the field symbol. Once the assignment is done, it is as equivalent as if you are accessing the memory. So when you change the data in the field symbol, it will directly change it into your row. So you're directly pointing the memory. That is the power of field symbol. So you need not have to do additional assignment, additional modify statement need not be written to change the data into the table, since you are directly accessing the memory. So all of these can be changed to two statements. I'll just comment it out. And here we will write our code for field symbol. So first I'll declare a field symbol. Like line of iTab. That's it. Same kind of declaration. Now, how do you read? When you're reading the data, the same syntax apply, only the assignment will be different. So instead of writing into work area, you will say assigning field symbol index 2. So now the field symbol which we have declared is going to point the second row. So in the second row, I want to change the content of B to Z. The value Z. That's it. Only these two statements are required to change your data. You need not have to do additional modify into the table, which can be sometimes risky. So now the same program will run. If I execute the program, you can see the data has been changed. But still, in the good program, it's not a good programming practice to use field symbols until or unless they are really required, because they may lead to dumps. Your program will be much faster because you are using field symbol, you are accessing the memory directly instead of doing the copying assignment and then copying the data back to the table. But field symbol directly doesn't consume any memory space. They directly point to the memory. So by that way, program execution will be fast. But as far as the practice is concerned, it's not a good practice to use field symbols until or unless you really need them. Because if I forget to do the assignment, it will directly lead to a dump. So let's say I comment out the read statement, and now when I'll execute, it will say field symbol not assigned. The program will dump. But on the other hand, with the work area, it wouldn't have been a case. Maximum, it wouldn't updated the data, but it wouldn't have dumped. So you can see here when I execute without assigning the field symbol, it says get one not assigned. That's the kind of error I'm getting here now. So it's not recommended to use field symbol every time. So now with that, on that note, we will move on to the next example, wherein we will see how to declare the data dynamically using ABAP. So this is a very important interview question as well. How do you create dynamic internal table in basic ABAP and using runtime type services? There are two questions. So there are two ways of creating internal table dynamically. So what is a dynamic internal table first of all? A concept of allocating the memory for the table whose structure is unknown. So you do not know the structure of the internal table which you want to create until runtime. So when you are executing your program, that time you'll get to know, okay, probably I want to create an internal table of this type of structure. Example, you've been asked to develop a utility program where user will provide a database table name. So user will provide you the database table name and you have to display the data of that table. So you have to display the data of that table and user will provide the name. So you are going to get the table name at runtime. So you cannot declare your internal table statically, because the syntax to declare internal table is data itab type table of, and here you need to give your structure name. So here you need to give your structure name. So right now we don't know the structure name. What is the name of the structure? With the help of that, I want to create my table. So that's why I cannot declare this internal table at design time. Design time means at the creation of my program. So I need to do some kind of magic to, to create the internal table at runtime so that it can hold the data which is coming from database layer. So that can be achieved using field symbols and concepts of runtime type services. So there are two ways. So first we'll see the normal way. So let's take the same example. I have a parameter which I will create t underscore name, or I'll use tab name, type tab name. So here user will give you the table name and you need to dynamically display the content of that table to end user. So if I execute this program, you will see that a table name is asked. Now I need to enter the table name, let's say Mara. and I need to display the data of this table to the end user. User may also give LFA1 for vendor, ANA1 for customer. So I do not know the table name at design time. So I need to declare an internal table at runtime. So to do that, what we will do is we need to follow these steps. The first step is we need to declare a field symbol which can point to table. So how to declare a field symbol which can point to any type of table? So let's declare that fi field symbol table type any table. This is the syntax to declare a field symbol which can point to any type of table in ABAP, whether it is typed or not typed, whether it is a structured table or not a structured table. Now, for any type of structure, we can use str type any. Then for any type of field, we can also use field type any. So that's my data declaration for field symbols. Now, and some memory objects using data. So data is a generic data type itself. So if you want to allocate the memory, you need to declare the data type using data keyword itself. So data, let's say dynamic memory, type ref to data. So that's how you will create your data, type ref to data. So this is a kind of dynamic memory allocation you are doing here. Now this memory will not be created until you write a special statement called create data. That we have to write. So now we need to allocate the memory of the table based on the name passed by user. So user will pass the name of the table into tab name parameter. So to declare the memory, we need to write a special statement. So in my step 1, declare all the symbols and dynamic memory. In my step 2, I need to allocate the memory based on table name passed by user. So user will pass the table name into tab name parameter. So how do I create the memory? Create data, dynamic memory, type table of the table name like this. So here the table name is my parameter that will be placed here dynamically, and it will allocate a dynamic memory which is capable of holding so much of data coming from this type of table. That's my step 2. Third, we need to assign this memory to the field symbol. So you can see in the picture that the table memory is created here. Now, in order to access this memory, you need to assign it to field symbol, because this is just a memory space. Until or unless you don't have a handle of this memory, you cannot access the data. So for that purpose, we need to assign it to the field symbol. So the third step is assign memory to field symbol. So how do we assign? Say we say assign the name of the memory star to any table. That's how you do assignment of dynamic memory to the internal table field symbol. So now this is the field symbol is equivalent to your internal table here. So whenever you want to refer an iTab, you actually refer to the field symbol only now. The fourth step, what we need to do now is select the data from database table and put that at memory using field symbol. So select star from my table name, that is tab name. So I'll probably select only 20 rows because I may have so many rows. I'll select only up to 20 rows into table and table. So this will select all my data from the dynamic table and place it to the memory space pointed by the field symbol. That's my step 4. Now my step 5, I need to read the data from dynamic memory using field symbols. So in order to understand data reading, we need to go back to the presentation and see how the data reading will be done. So you have a table memory which is composed of rows and columns. So field symbols of any table type is pointing to this table memory. Now my purpose is I want to access a particular cell. So first of all, I need to assign a row of this table to my line field symbol, which is a structure field symbol. So one of the row I will assign from the table to the structure. So how do we do it? That's pretty simple. You just do a loop over internal table and assign to the structure, same way. So from this dynamic internal table to the dynamic structure, we need to assign it. So first is loop at internal table, which is your any table, assigning to structure. So now one by one row will be assigned. So it will, let's say, have 20 rows. So first row in the first loop path will be assigned to the structure type, structure field symbol, which can point to any type of line. Now within this loop, one structure is composed of so many fields. Let's say if I say bara structure, it has material number, material group type, material plant, all this information. So one line is composed of so many fields. It's a collection of fields. So each field you need to assign one by one to the field symbol which is pointing to a field. And how do we know how many fields are available? We don't know in which structure how many fields will be there, because every time this structure length will be different. The number of fields based on data type will be different. So for that, we'll write an infinite while loop to keep on looping through the fields until and unless we reach till the end of the fields. So how do we do it? We'll write an infinite while statement, while 1 equals to 1. And in here, we will try to assign component psi-index. It's a system variable for loop counter. Assign component psi-index of structure str to my field. So in first loop pass, the first component of the structure, which is the first field, will be assigned to this field symbol field. In next loop pass, the next particular field will be assigned to this field symbol, which is pointing to the field, and so on. So when the assignment is not successful, so if sub RC is 0, not equal to 0. So if let's say there are two fields, so after the second loop pass, in the third loop pass, this assignment will fail. That time sub RC value will not be equal to 0. So I will exit out of this infinite while loop. And below this, I will print the value. So I'll write a write statement to print the field value. And after this loop is done, infinite while loop, I'll come out of it. One line is completed. So I'll enter a blank line. I insert a line. So the next row will be printed in the next line. That's it. My job is done. Now, as we have seen that we have allocated table memory, the field symbol is pointing to it. I will read the row of this table into a row type field symbol, and then I will access the components uh, of this structure, or I will access one by one field into infinite while loop until the assignment is happening. So that's a purely dynamic program, and now I execute it. I will give the name of table as Mara, or let's say I'll give it as KNA1 for customer master. Oops, it dumps. So it cannot find the KNA1 as the data type. So probably that's not a correct table in my system right now. I go to SE38 again, execute the program with a different data type. I use SCAR. SCAR is a data type for flight details, all the airline codes. Yes, you can see it has retrieved the data from a SCAR table and showing me all the airline codes. I go back and change it to SPFLI.
Show me the debugging mode of this 5-step mapping. Okay.
The question?
Is it possible to show in the debugging mode the 5 steps how it happens?
Yeah, we will see.
Like
So
how
now I
the
go back and set a
pointer.
breakpoint.
Okay.
And execute this. So I use a different table name this time. So different table name will be passed to the program. So dynamically an internal table has to be created with this type now. So it's entering into the debugging now. You can see here the table name is SPFLI. That's my dynamic memory. Right now it is initial. As soon as the create data statement will be executed, I will have the memory created. You can see now it has acquired the table memory, and since my SPFLI table has 16 columns, it has acquired 16 columns. So this dynamic memory is exactly equivalent to my table now. But in order to access this memory, I need to use the field symbol. So when I double click on the field symbol, you can see field symbol is not yet assigned. When I do F6, the field symbol assignment is done. Now when I double click, I can see it is pointing to that dynamic memory. So field symbol is the only way to point to that dynamic memory. It's a handle of that memory. Now it selects 20 rows from the table. Since there are not at all 20 rows, only 15 rows are available. Those 15 rows are selected. Now in the first loop pass, it will take the field symbol from the table and assign the first component of the table. The component of the table is a row. So it has taken the first row of the table. You can see that's my first row of the table. And now within this, it will start looping through this row or the cells which you have and print one by one cell value on the screen using infinite while loop. So it enters into infinite while loop. Assign index value is 1 right now. So it will assign the first component of the structure, which is my first field, to this field symbol field. So my first field is the client field. You can see it has taken the value as 001. Now it prints the value, goes to the next loop pass. Now the psi index value is 2. It takes the second component. The value is carrier ID, which is American Airlines AA. and it will be keep on assigning the components like this until it reaches to the end of structure. So until it reaches to the last field. So the last value of sign index will tell me what is the value of my last field. So there are 17 fields. Sorry, there are 16 fields. So when the sign index value is 17, there is no component which can be assigned now. So it comes to the exit of while loop. So that's my first row end. So it comes out of while loop, prints a new line, and then it reads the second row and does the same thing for second row as well. So it shows all the content of SPFLI table to me on the screen. I can give another table as flight, which contains the flight details. Connecting to debugger, same process happens again, and it shows me the flight details on the screen. So that is your dynamic internal table. So this is the basic approach of creating a dynamic internal table. Here we have not used the object-oriented programming paradigm to create the dynamic memory. So now we will change this program to object-oriented approach, wherein we can create the dynamic memory using object-oriented approach. For that, what we use ABAP runtime type services. What is ABAP runtime type services? Runtime type services are nothing but set of classes, standard classes provided by OOPS ABAP objects to us. Why they are used? These classes allows you to get the definition of variables or create them during program execution. So you can create any type of variable, whether it's a structure, table, or a single variable based on the types you need at runtime. That's why the name is runtime type services. So RTTS is made up of two components. One is RTTI and RTTC. First is the runtime type identification, which is used to get the definition of existing variable or existing types. For an example, I give a structure name, which is like in this case, I'm giving in the parameter. So I need to first identify the type using runtime type identification class, and then runtime type creation. I need to do it using create data statement. And this time I will use a new keyword called type handle. So RTTI and RTTC may be called using method CL underscore ABAP underscore star descriptor. Star means here you will give your type class name. If it is related to structure, so it will be structure description. If it is related to table, it will be table descriptor class. So now whatever example we did here, we will try to change it using runtime type services classes. So to do this, what you need to do here is, you need not have to create this dynamic memory type ref2 data. That is not required. So I'll just move this program down. I'll copy the program and we'll try to do it using runtime type services. The first thing which will change here is the data declaration need not be done. It should be a declaration of runtime type identification class. So first I need to use hello structure type ref2 cl underscore abap underscore. Now I wanted to create a structure object first of all. So it should be structure definition str. So it should be the structure descriptor class which I need to refer it to. So cl underscore abap underscore structure descriptor. Next I want to create a table descriptor. So I'm basically creating a handle of runtime type service classes. So instead of structure descriptor, now I will use table descriptor. And instead of this create data, dynamic memory type table of this table name, I will not use the table name. Instead, I will use handle. Actually, I need the dynamic memory object, but the allocation will happen using the runtime type service classes. So create data dynamic table, type handle, the table descriptor class object. Now, as far as step 1 is concerned, we will have another step here to obtain the objects of runtime type service classes. So instead of direct allocation, we have to create the dynamic memory based on the object of runtime type service class. So now you need to obtain this object first of all. To obtain this object, we use a standard type descriptor class, and we'll use, so I use standard type descriptor class and say create. So I'll call the create method, or I'll use describe by name method. So in this, I need to pass my structure name, for which it will dynamically create an object which is referring to dynamic type. So p name is my structure name. That is basically my table name passed from above. I'll remove rest of the code which is unused. So that's my first object creation. So now type descriptor class described by name will give me an object of this particular table type. So this will give me the runtime type identification object. Now if you'll see what is the returning type of this, the returning type of this is CL underscore ABAP underscore type descriptor. You can see returning value P underscore descriptor reference. So this particular method will return me a type CL underscore ABAP underscore type descriptor. But here I need an object of CL underscore ABAP underscore structured descriptor. But it is giving me the base class object. So now if you remember in the basic concepts, we have written that when you want to get an object of child class from the super class object, you need to typecast it. So if I go to structured descriptor class, you can see it has a parent class as complex descriptor. And when I go to the parent class, it has the parent class as data descriptor. And on top of that, you have the type descriptor as the base class. So your structured descriptor class is actually somehow a child class of type descriptor class. So right now you will get the object of this type descriptor class, but you need to typecast the object to the structured descriptor class. So when you want to typecast a base class object to child class, it's a widening cast concept. So in order to bring this object, you need to use widening cast question mark equals to. So whatever object it is giving, it's a type descriptor. You have typecasted it to the structured descriptor. Now using table descriptor class, you can create the memory for table. You can create a handle for table descriptor. So when I create this, the line type, I will pass the structure object. And pass that into the table. That's it. So that's how you obtain your table descriptor object. First you obtain the structure descriptor object using standard type descriptor static method described by name. Since it gives the object of base class, but we need object of child class, we will do a widening cast. After that, we will call the create method of table descriptor and pass the structural runtime type identification object to it. So that finally gives me a RTTI object of handle. Using this handle, when I say create memory, it will allocate the memory for the table. So these objects you need to obtain in order to create the dynamic memory using runtime type service classes. I'll activate my program. And now when we will execute it, it will behave in the same way the way it was doing for normal. So let's execute. I type the scar as the table name. You get your result. I type S flight. You get the flight data. Now you may probably have this question in mind that then what is the difference between these two approaches? Because earlier approach was looking more simpler. You have directly put the type table of and in the braces you put the table name. But here I have to do additional processing to bring these structures, to bring these objects and a lot of typecasting. The main difference is using of object-oriented approach. You are using an object-oriented approach to get the objects. And these objects will be responsible for creating the dynamic memory. That is first difference. Another difference is this kind of case wherein you will get the table name for at runtime. It is simpler in the old approach, wherein you can directly say type table of and in the bracket you will pass the table name. It is simple. But when you get a table which has the components, let's say I get an internal table which has the components like columns which I need to create, that time the old approach will not work. So let's say I get a table of metadata wherein I have the information about columns which needs to be created. So that time I will not be able to create that using the old approach. I have to use runtime type services to create the object of that table. So that's how we will create the runtime data allocation using RTTS. And all the steps to create that are given here in this. You can ask any doubt if you have.